Okay, look at that. 1s2. Okay, so 1s2 here means the 2 electrons are present, and these 2 electrons are present in s orbital of first cell. That's the way we need to understand. Okay, 2 electrons are there. Here you can see the power. 2 electrons are there, and these 2 electrons are present in the s orbital, and this s orbital is of first cell. If you remember, 1s means s orbital of first cell, right? 1s2. So that would be this is finished. Electronic configuration of hydrogen is 1s1, of helium 1s2. Okay, now after that comes lithium. And now look at that. 1s2. Okay, this comma should be down there. That's comma. Okay, this thing. 1s2, comma 2s1. Okay, this comma should be here like this. 1s2, comma 2s1. Now 2s comes. You cannot write 1s3, right? 3 electrons are present in lithium. 3 electrons are present in lithium atom, but all 3 electrons cannot be present in one s orbital because one s orbital has capacity of only 2. So now third electron has to jump to next orbital, and in that order. Okay, if you remember what is the order here, let me write here. Okay, first we fill 1s, right? Here first we fill 1s, then comes 2s, right? And then comes 2p. After 2p comes 3s. After 3s comes 3p, and then 4s, and then 3d. This is the order that we need. First we fill 1s, then we fill 2s, then we move on to 2p, 3s, 3p, 4s, and 3d, right? Okay. So here in this case, 3 electrons are there. So 1s2, then 2s1. I hope you're understanding this. Why 1 electron is jumped to the next orbital. Okay. Now after lithium, okay, beryllium. Now you can try it yourself. I hope you are writing also. Please write down. You should be writing these things. Now beryllium, you are going to write yourself. Okay, please everyone, you write there beryllium. So what should be the electronic configuration of beryllium? Come on, you try it yourself. Try it yourself. Everyone, I know. Please write. And those who are using mobile device, what you can do is you can turn on your back camera and show me what you are writing. Okay, those who are using mobile device, for them it is easy. Just turn on your back camera. Turn on your back camera and show me what you are writing. Okay, so with one hand you can hold your phone, and with the other hand you can write. Oh yeah, Saradi is doing that. I can see. That's good. So those who are using computer, for them, okay, not possible. For them, what they can do is first finish writing and show me on your webcam.
Sir, can we take a snapshot?
Yeah, okay, that's fine. But like somehow I need to see now. Like show me, send me your file or okay. So yeah, Kashyap is showing me. I can read that. Okay, Kashyap, fine, done. Okay, Kashyap, I saw. That's correct. Okay, so that's easy way. And
Sir, I will also see.
are they still having problem to turn on the back camera? And what about Bikram? Come on, do as I'm saying here. I said turn on your back camera and show me your copy. Okay, you should be showing me, and I think I can see. Okay, done. Yusuf, okay, fine, I saw. The others have to show me the same way. Okay, who is showing Dixie? Okay, fine, Dixie, I saw. Okay, Dixie, done. Okay, if you have finished writing, you can show me on your webcam. It's easy thing. Okay, Bikram is showing me, but it's not that very clear. Okay, Aparajita was not there some time ago, I guess. Or what happened, Aparajita?
Our line gone.
Oh, line means
Sir,
electricity
my
or
also
internet?
it was cut off.
Just now it came.
Okay, it happens.
Yes, sir. Our also line was cut off.
I know, sir.
Oh,
Just now came.
Yeah.
Okay, and really, like, I mean, in your absence, you missed one very important concept here. Talking about electronic
Yeah.
configuration here. Lakshmi Das is showing me, and okay, I think that's correct. Okay, Lakshmi, that's correct. Fine. Okay, so Naman, what happened? Why you are not showing me anything? Okay, Arati is showing me 1s2, and what is that? Okay, correct, correct. Okay, Arati, that's correct. And Kanchan and Sumana. Whose work is that? Kanchan or Sumana? I don't know. So me. I haven't seen. It's very difficult. Okay, I think that's correct. Okay, okay, fine. Okay, Kanchan, that's fine. Okay, Christina is showing me, but I didn't see it. Show me again. Okay, okay, that's easy. 1s2, 2s2, right? 1s2, 2s2 is the correct answer, and many students have not shown. I don't know what they are doing there. This should be now easy to understand here. Okay, after lithium, what comes? After lithium comes beryllium. Beryllium atomic number is 4. That means there are 4 electrons, right? So 4 electrons we have to distribute among those orbitals. So first orbital to fill is 1s. 1s can have maximum of 2 electrons, right? 1s2. So now 2 electrons remaining. 2 electrons will go to the next priority, and the next priority is 2s here. You can see the order here. Okay, order of that energy. So after 2s comes 2, sorry, one after 1s comes 2s. 1s2, 2s2. Okay, that's the answer for beryllium. That comma should be there. Okay, after beryllium comes boron. Okay, so boron. Okay, now let's write of boron. Okay, I'm not going to write myself. Okay, everyone, I know you write yourself. Try, Gavin. Come on. Don't wait for me. 1s2, comma 2s
Hydrogen.
2s2. Then comes 2p1. Okay, that's the answer. 1s2, 2s2, 2p1.
Hydrogen.
Okay, that's
Helium.
boron. Okay, that's boron. 1s2, 2s2, 2p1. So here also like the same concept I'm putting here. Okay, first orbital, 2 electrons possible. Okay, that's 1s, 1s2. So now 3 electrons left.
Yeah.
Those 3 will go on to second possible orbital, which is 2s. But all 3 cannot adjust there also, because 2 is the capacity for s orbital, right? 2s2, that's right. The last electron, 5th electron, will jump onto the third possible orbital, which is 2p, according to our this energy level order, right? That's for boron.
Beryllium.
Okay, let's change the color here. I'm not liking this color. Let's use green color. The beryllium, boron. After boron comes what? Carbon. Okay, carbon. So 6 electrons. How to distribute 6 electrons among those orbitals?
1s2, 2s2, 2p2.
Okay, come on, do it yourself. 1s2, 2s2, 2p2, right? Someone already said. I think Deepika said that, right? Okay, 1s2, comma 2s2, and after that no comma, 2p2. That's carbon. Okay, after carbon, like a nitrogen oxygen also will be very similar. Now I should jump now. But you write. Okay, I will jump doesn't mean you also jump. You don't jump. You write it. And you keep on writing like serially. Okay, after carbon, what comes? You know that. Okay, write of that. Nitrogen oxygen now will be easy. 2p3, 2p4, like that. Very simple, right? So now I will jump on to the sodium. Okay, so where shall I write here? Okay, writing here. I hope you can see. This is good. Sodium. Okay, I'm writing here. Sodium Na. Okay, sodium. Okay, you can write, keep on writing like I don't know where you reached, but here I'm writing up sodium. So atomic number is 11, right? Atomic number is 11. So that means there are 11 electrons. Okay, now let's follow. First orbital to fill is 1s, which is 2s. 1s2, comma. Then comes 2s. Okay, 2s2. Then comes 2p6. Okay, no more than 6 because p has capacity of 6 only. We cannot put 2p7 there. Okay, 2p6. And then we put comma there. Then comes 3s. 3s1. Okay, so that's the answer for sodium. 1s2, 2s2, 2p6, 3s1. 3s1. That's sodium. Okay, if you are having any problem, like better you ask, like how I'm doing this. Naman, are you understanding what I'm doing? Are you understanding what I'm doing here?
Yes, sir, I'm understanding.
Sorry.
Yes, I'm sir understanding. Little.
Really? But I have a little doubt about you understanding or not. In that case, you tell me of aluminium here. Okay, you tell me aluminium. Okay, no need to write. Just tell me. Like 1s2, 2s2, you can tell. Come on, try. Aluminium, tell me.
Sir, 1s2.
Mm-hmm.
1s2. 1s2, 2s2.
Mm-hmm.
2p. 2p.
2p.
Sir, 3s.
2p what? Tell me the number there. 2p what? 2p what?
No, sir, not 2p, sir. 3s.
2p will not be there.
So there will be 2p.
Okay, then tell me number. No, on top there should be number. If you see, all the orbitals are having some number, right? And these numbers
Yes,
actually
sir.
represent electron number. So this 2 means 2 electrons present in the s orbital. Okay, so here also obviously 2p only you cannot say 2p what? 2p1, 2p2, 2p3, 2p4, 2p5. Okay, what should be there? 2p what?
2p7. Sir, 7.
2p7. Oh. Okay, my doubt was like very much correct. You have not understood this. Okay, Naman, listen carefully and focus more. Please look there. How I'm doing it. Aluminium, 13 electrons, right? 13 electrons we have to fill. And order we know 1s, 2s, 2p, 3s. After 3s comes 3p, right? Okay, so now let's start writing. Okay, I'm writing here. Okay, 1s, 2, right? After that, okay, comma, don't forget that. Then comes 2s2. Okay, and then okay, so now just count 2, 2, 4. 4 electrons finished. But still we have 9 electrons more, right? So after 2s comes 2p. Okay, after 2s comes 2p. Now let's see. Okay, what is the capacity of p orbital? P orbital has capacity of 6. You need to memorize. S orbital has capacity of 2. P has 2 plus 4, 6. Okay, and D has plus 4, 10. F has plus 4, 14. So that is the capacity you need to memorize. Memorize the capacity of the orbital and then memorize the order of the orbital. That much you have to do. Okay, so that means 2p6 is possible here. You cannot write 2p7 or you can write 2p5 because capacity is 6. So maximum capacity you can put there 2p6. Now if you count how many electrons are finished, 2 plus 2 plus 6, 10 electrons are gone. Now how many left? 3 are left. So now we have to move on. After 2p comes what? 3s. 3s can have maximum of 2 electrons there. Okay, so 12 electrons gone. 12 electrons gone. 1 electron is still left. Obviously you cannot write 3s 3. Okay, 3s as capacity of only 2. That's why after 3s comes what? After 3s comes 3p. 3p1.
Sir, 3p1.
Right. 3p1. 1s2, 2s2, 2p6, 3s2, 3p1 is the answer for aluminium. Okay, come on, right. So this okay, this one is looking a little bit mess here. Let me clear this everything out here. Oh, let me rub using the eraser. You want to rub this beryllium? I'm rubbing it. Beryllium, beryllium, go away. Go not to go.
Excuse me, sir.
Yes, you can ask.
Sir, if there are less than 6 electrons, then we cannot put it into P5 4 like that.
Sorry. Ask me again. What did you say?
If there are less than 6 electrons in P orbital, then can't we write 2p4 5 like that?
Yes, we can do. Why not? Like, for example, after carbon, what comes? Nitrogen, right? So, for nitrogen, how you will write? Nitrogen, 7 electrons are there. So, you will write 1s2, 2s2, and then 2p3, right? Okay, so it's about how many electrons you have, right?
Okay, sir.
The p orbital can have maximum 6, doesn't mean it can have only 6, right? It can have 1, 2, 3, 4, 5, anyway. It cannot more than 6. It depends how many electrons you have got. So here, like, in the case of aluminium, obviously you will not write 3p5. Okay, you cannot write 3p4. Okay, because no electrons left there. You have to make it 3p1 because only one electron is left. Okay, it's very much like K11. In K11 also you do the same way, right? Okay, in K11 also you do the same thing, I guess. No difference. Okay, only easy thing was, K11 was like easier because only 4 cells are there. K11, first cell K, second cell L. So in that way it was kind of little easier. But in this case, there are more orbitals. Okay, there are more orbitals and names of the orbitals also kind of confusing there. 1s, 2s, 2p. So that's why. Otherwise, if you remember that order is very important thing. Okay, I have written this. Okay, the pink order here. Can you see 1s, 2s, 2p, 3s, 2p, 4s, 3d? Okay, this order to memorize completely. If you memorize this order, okay, and if you remember that capacity, okay, like 1s, what's the capacity? 2. Okay, 2 here, 6 here, capacity 2 here, 6 here, 2 here, 10 here. Okay, if you remember this capacity and this order, then it's done. It is very much like KLMN. Okay, it is very much like KLMN. Easy if you understand. Okay, but if you don't understand, it could be a little difficult. Okay, so I hope now there's no confusion. Now let's keep on moving. Okay, keep on moving. That means till aluminium I finished. I'm not sure how many you have done that. So you
Sir, I have finished all up to calcium.
have also completed up to calcium.
Up to calcium, sir.
okay, up to calcium finished. Okay, that's very good. So now let's see. I wanted to explain about that strength thing. Why not 289? Why not 2810? Yeah, class 8 question. So for that, I need electronic configuration of potassium. Okay, now let's see potassium here. Okay, so I need to clear out this thing here. Yeah, let me rub this aluminum here. Okay, let me rub this all here. Okay, so let me write off here the potassium. Okay, if you have already written, you can you can compare yours with mine here. Okay, I'm writing off potassium. 19 is the atomic number, so 19 electrons we have here. Okay, so 1s2, right? 1s2. Okay, 2s2 confirm comma, and then comes 2p6, then comes 3s1, then there is 3p6, and then comes 4s1. That's the configuration of potassium. You can add there 2 plus 2 plus 16, and then again this is 2, I think 3s2. Okay, then 2 plus 6 plus 1, yeah, 19, yeah. 2 plus 4 plus 16, 12, 18, 19. 19 atomic number, 19 electrons are adjusted in this way. Okay, so now let's compare. Okay, let's compare here. Okay, now let's try to convert this into KLMN. Yeah, I hope you understand this thing. 1s2 is actually K cell, right? 1s2, 1s orbital is the orbital of first cell, K cell. And how many electrons are present there? 2, right? Yeah, I'm just like comparing this thing, comparing. Okay, let's use different color. Different color. Which color to use? Wait. Okay. Wait. Okay. Come on, like this. Okay, it's like look at this. What I'm doing here. Okay. So now you can take a look at this is fossil, right? This one is fossil, 2s2p, second cell, 3s3p, third cell, and 4s, fourth cell. Okay, now we can add that. How many electrons are present there? 2 electrons, right? 2 electrons in the fourth cell. So here 2 and 6. You need to be understanding here. This 2s and 2p are both the orbitals of second cell. It's like two different rooms of same flat. So it's like electrons are number of people inside those rooms. So how many total electrons are present there? Okay, you can say 8 electrons, right? 2 plus 6, 8. So that's of L cell. Similarly, now let's go to M cell then. Okay, 2 plus 6, 8 are there, right? And the fourth cell single. Look at that. 2881. This justifies what we have done last year in class 8. Now, if you ask why not 289? So 289 was possible if 3D would come before 4s. Okay, again, in that Abbas principle, the energy is being talked. Okay, that law says that we have to fill the electron in that orbital which has got low energy. And according to that rule, okay, the 3D and 4s, out of 3D and 4s has low energy. That's why 4s is filled. But just imagine if 3D would have come first, like if 3D would have come earlier than 4s, then the case would be 3D1, right? It would be 3D1. Then it would have been 9 possible, 289. So why not 289? Because 3D is not filled, okay, before 4s. 3D is filled after 4s only. Okay, that means the 9 also can be possible.